Hi there. We talked today in class about reading graphs in order to identify certain characteristics of our function, our graph of f of x. And we looked both at reading graphs of f as well as graphs of f prime. And so we did 6 graphs as notes. I've gone ahead and prepped 3 for us to kind of practice here together. They are the ones that correspond to your notes, so for those who were in class, you will have already seen these, but it's a good kind of reminder, a good refresher. For those who were absent, you can print off the notes if you want to follow along with me. I've also gone ahead and uploaded the full filled out notes onto my website, so you can choose which one you'd like to print out. Okay, so the first thing, before we actually get into reading graphs, we do want to make sure we've considered a couple of definitions, a couple of relationships that are going to come into play with these graphs. The first one is what it means for f to be increasing. And we utilized this fact in our first derivative test. F is increasing when f prime is positive. Right? Because f prime, remember, is the derivative, it's the slope. When the slope of my function is positive, my graph is going to be going up. Okay? And then the opposite would also be true. F would be decreasing when f prime is negative. Okay? Okay, so we have f is increasing when f prime is positive, f is decreasing when f prime is negative. Okay, so the other one that we want to consider is our concavity. Right? Where is f concave up? So this draws on the definition of concave up. F is concave up when f prime is increasing. And when we were solving these problems analytically, for concavity, we'd use our second derivative. We'd put it on our number line, right? Our second derivative, we'd be looking for where it was positive. So f is concave up when f prime is increasing, when f double prime is positive. Okay. And then the opposite, f is concave down, drawing on the definition of concave down, when f prime is decreasing. And on our number line, we'd be looking for where f double prime is negative. Okay? So these are the relationships we're going to be using, especially when the graph we're looking at isn't a graph of f, but our questions ask us about f, right? When our questions ask about one function, our graph is something else, right? We're going to be drawing upon our relationships here, our definitions. Okay? Okay, so let's go ahead and take a look at the first graph here. We need to take note when we initially get a graph specifically at what the graph is of. This graph is of f prime. And so everything that I'm going to be asked, I'm going to reframe with the lens of an f prime graph. Right? So for example, over here I'm asked for where is f increasing? Well, I know what it means for a function to be increasing. It means it's going up, but unfortunately this is not f. This is f prime. And so I need to reframe this. I need to translate it, if you will. I need to translate it into terms of f prime, because I've got f prime as my graph. Well, f is increasing, remember, when f prime is positive. And so when I'm asked where's f increasing, I'm on an f prime graph, I'm going to be looking for where's f prime positive. Well, f prime is positive if it's above the x-axis, and f prime is positive, it's above the x-axis here, from -3 to -1, right? -3 to -1. Remember, we're talking x values, not y values. So -3 to -1. And it's also increasing, f prime is also positive, here, from 1 to infinity. And a reminder, I'm putting infinity here not because I'm going up. I'm not talking y values, I'm talking x values. I'm putting infinity because I'm going right. Okay, f is decreasing. Again, it's not an f graph, it's an f prime graph, so I have to translate it. What does it mean for f to be decreasing? F is decreasing when f prime is negative. And so because I have an f prime graph, when I want to answer where is f decreasing, I'm actually going to be looking for where is f prime negative. And f prime is negative down here from negative infinity all the way to, that's x equals -3. and from -1 over to 1. F prime is negative when it's below the x-axis, -1 to 1. Okay? For our minimums and maximums, a minimum occurs when my f prime changes from negative to positive. Right? Maximum occurs when it changes from positive to negative. And right, we've been doing this since our first derivative test. We'd be putting these on an f prime graph, we'd test our numbers and we'd look on both sides. And if it went down, if my f prime was negative, and then up because my f prime was positive, then I had a minimum there. And so that's what I'm going to be looking for on my graph too. I'm going to be looking for where does my f prime change signs. If it goes from negative to positive, it's a minimum. If it goes from positive to negative, it's a maximum. Okay, and so then the question was, well, what did I put on my number line when I was solving these problems analytically? Right? To break my intervals, I would have put on my discontinuities and I would have put on my zeros. And so I'm going to go ahead and identify that right here at -3, I have a 0. And so that's going to make its way onto my number line. I also have a 0 here at -1 and a third 0 here at 1. And then just like we do on our number line test, we're going to be doing the same thing with this graph. We're going to look on either side of those critical numbers, right, on either side of those zeros and see what is my sign. What's my sign of f prime? Well, on this side of -3, right, left of -3, my f prime is below the x-axis, and so my f prime is negative. Right? Between -3 and -1, my f prime's above the x-axis, so it's positive. Between -1 and 1, it's below the x-axis, so it's negative. And right of 1, it's above the x-axis, so it's positive. And so I can draw in my arrows to help me see my mins and my maxes. Relative mins and maxes, I should say. So I have a relative minimum here at -3, and another relative minimum here at 1, and I have a relative maximum at -1. Okay. Okay, so the last three here all deal with our concavity. F is concave up. Again, this is not F, so I can't look for the cup shape, right? Concave up like a cup. Okay? It's not F, so it's not going to look like a cup. It's an F prime, and so I need to translate it again. What does it mean in F prime for F to be concave up? Well, F is concave up. Right here, F is concave up when F prime is increasing. F is concave up when F prime is going up. It's increasing. Okay, so that's what I'm going to be looking for. Where is F prime increasing? Well, F prime is increasing on this whole section of this graph right here. Right? From -infinity up to -2. It's also increasing on this section from 0 to infinity. F concave down. Again, we have to translate. F concave down is when F prime, slide this up here, F is concave down when F prime is decreasing, when F prime is going down. So that's what I'm going to be looking for on my graph. F is concave down when F prime is decreasing. F prime is decreasing right here. It's going down from -2 to 0. And then the final step here is, where are your points of inflection? Your points of inflection are where our function, our f of x, changes concavity. It was concave up and became concave down, or vice versa. Well, here my f was -infinity to -2, concave up, and then at -2 it became concave down. It switched to concave down, so I have one point of inflection at -2. I have another point of inflection then at 0. I went from concave down back to concave up. Okay. Okay, so the next graph here is an f of x. Right? The f of x's are nice because there's no translation necessary. We are given f and we are asked about f, and so it's going to be a very straightforward answer. Right? I want to know, where is f increasing? Well, that's f. So where is it increasing? Where is it going up? F is going up here from -infinity to -2, and here from 0 to 1. Right? Where is f decreasing? Well, That's f. So where is it decreasing? Where is it going down? It's going down here from -2 to 0. And here from 1 to infinity. Okay. Relative minimums. It's a graph of f, so I just have to look for the minimum. Where's that valley? Well, I have a valley right here at 0. And relative maxes, it's a graph of f, so I just look for the relative maximum. I look for those hills. I have 2 hills, one here at -2, one here at 1. Okay, so now we're on to concavity. Concave up, up like a cup. So I need to look where it's up like a cup. And it's up like a cup right here. And so I need to figure out somewhere in between, because this is concave down, this is concave up. Somewhere in between here, it had to have switched, right? And so probably switched right about there, about the halfway mark. And it is a rough estimation. So we're going to be switching. We're going to say we're switching from concave down to concave up at -1. And so our concave up piece goes from -1 to, and then again, we notice there's going to be a switch, and so we've got to have another point of inflection in here, probably somewhere right around here, right around 0.5. So I'm going to be concave up from -1 to 0.5. Okay. And then I'm going to be concave down from -infinity to that first point of inflection, which was -1, down like a frown. And concave down from 0.5, that second point of inflection, to infinity. So my points of inflection in this particular case, I switched from concave down to concave up at -1, and from concave up to concave down at 1/2. Okay, so again, F's are nice. There's no translation necessary. It's just a straightforward answer from the graph. Okay, so last one here. Another f prime graph. And so again, notice my questions are asked about f, but I'm given f prime, so I'm going to have to translate again. So where is f increasing? I don't want to look for where it's going up. This is not f. I can't look for where it's increasing. I have to translate it. So f is increasing, remember, when f prime is positive. And so that's what I'm going to be looking for. F is increasing when f prime is positive. Well, f prime is positive here, from -infinity to -2.5. And f is increasing, f prime is positive, from here at 0.5 over to about 1.5, probably more like 1.4. It looks like it's a little bit less than half, but we're going to go ahead and call it 1.5. Okay, f is decreasing, then you have to translate it that as well. F is decreasing when f prime is negative. And so that's what I'm going to be looking for. Where is f prime negative? Well, f prime is below the x-axis here, which is from -2.5 to 0.5. And here, on this last part of the graph, from the 1.5-ish number that we talked about, out to x is infinity. Okay, mins and maxes, we need to test them. We need to see where am I changing from negative to positive or positive to negative. So again, on my number line, I would have put my discontinuities and my critical numbers. So I'm going to go ahead and put on here, and cusps. I almost forgot. Discontinuities, critical numbers, and cusps. Everything we did with the analytic. You're just going to mirror that here with our graphs. So I have 1 0 here at -2.5. Another 0 here at 0.5, and a third 0 here at the 1.5-ish. Okay. And so then we're going to be testing signs. So I need to look here, left of -2.5. The left of -2.5 is this part of the graph. It's above the x-axis, so it's positive. Between -2.5 and 0.5 is this part of the graph. It's below the x-axis. It's negative. Between 0.5 and 1.5 is this piece of the graph. It's above the x-axis, so positive. And right of 1.5, right of 1.5 is this part of the graph, which is below the x-axis. It's negative. And so I have a minimum here, a valley at 0.5, and I have two maximums, one here at negative 2.5 and one here at 1.5. Okay, last three. Concavity, F is concave up. Remember, F is concave up when F prime is increasing. So where is F prime increasing? F prime is increasing here from negative 1 to 1. Okay. F concave down. Is concave down when F prime is decreasing. And F prime is decreasing here from negative infinity to negative 1 and from 1 to infinity. So then last step, point of inflection occurs when F changes concavity. Well, I notice here that it's concave down from negative infinity to negative 1, and at negative 1 I switched. And so negative 1 is one point of inflection. And then my second point of inflection is concave up from negative 1 to 1, and I switched. And so my other point of inflection is at 1. Okay. So that's demonstrating reading F and F prime graphs. A couple of kind of quick pointers here, just as a reminder. You are not guaranteed to have a minimum or a maximum, right? In fact, you aren't even guaranteed to have a point of inflection, to have both concave up and concave down, right? It all depends on what the function is, and so you're going to see that in these graphs. In this particular case, we had one of each, right? But that doesn't necessarily have to be true. It depends on the graph, it depends on the function, and so make sure you're always keeping that in mind when you are reading your F and F prime graphs. Okay? And there you go.